Okay, kids, in this video, what we're going to do is we're going to look at finding the area of other polygons, okay? And in order to do that, we're going to start out by looking at some basics. Polygons are closed-sided figures that are made up of line segments, angles, and vertices, okay? And we have already gone over finding the area for squares and rectangles, and we would use the formula of length times width. And then we talked about finding the area of a parallelogram, and we discovered that that formula would be base times height to give us the area of a parallelogram. And then we went into the area of triangles, and the formula for that, finding the area of a triangle, would be 1/2 times the base times the height. Then what we did was we moved on to the trapezoid, and we discovered that by decomposing shapes, breaking them into other shapes, such as taking them and breaking them down into squares and triangles, we find that it's much easier to find the area of those polygons. So when we talk about finding the area of a trapezoid, basically we're breaking it down or decomposing it into some of the basic shapes that we already know the formulas for. Okay? So anyways, let's take a look at some further information. Being able to compose or decompose polygons is very helpful when it comes to finding the area of a polygon. So if you look at the polygon we have over here, what we're looking at is we have an 8-sided figure, which is an octagon. And if we wanted to decompose this figure, what we could do is we could pick a couple vertices and start connecting lines. Now, how you want to do this is really up to you. My preference is just to kind of like do it in the following fashion, okay? I'm going to take and create my dotted lines, okay? And so what I like to do is, for me, I see a rectangle right across this way, okay? And so if I wanted to figure out the area of this rectangle now, I know that it would be 2 centimeters plus this distance here plus this distance here, okay? And this distance is 2 5/10 of a centimeter because this is equal to that, all right? And so I could begin decomposing my shape that way. The other thing I like to do with octagons is to divide them up like this, decompose them like that. Now what you have here is you're dealing with squares, rectangles, and triangles. And those are fairly easy to find the area of. So let's take a look at how we would actually get the area of this octagon. Okay? Well, the first thing that I'm going to look at is I'm going to look at the square. Okay? And I'm going to find the area of the square. Okay? Now the square, of course, has sides that measure 2 5/10, okay, 2 5/10, and then this side, of course, is got to be 2 5/10 as well. So if I take 2 5/10 and I multiply those together, that will give me the area of my square. So 2 times 5, or 5 times 5 is 25, regroup my 2. 5 times 2 is 10, plus 2 is 12. Marker 0 to hold my place value. 2 times 5 is 10. Regroup my 1. 2 times 2 is 4, plus 1 is 5. Add my partial products. 5 plus 0 is 5. 2 plus 0 is 2. 1 plus 5 is 6. Decimal point over 2 place values, because it comes out 2 place values. So I come over 1, 2 place values and put my decimal point. So the area of my square is going to be 6 25 hundredths of a centimeter. Okay, and so what I'll do is I'll erase some of my markings here, and I'm just going to record that amount right inside there. So I'm going to do 6 and 25 hundredths of a centimeter, okay, for that square. Well, now I can go and I can work on the rectangles, okay? So if I look at the dimensions of the rectangle, I would say, okay, the one side of the rectangle, I'm going to call this my length, is 2 5/10. Okay, so my rectangle is going to have a length of 2 5/10 and a width from here to here, which is determined by this measurement, of 2 centimeters. So now all I have to do to find my area is multiply, and 2 5/10 times 2 would give us 5. Okay, now here's the thing. This rectangle right here will have an area of 5 square centimeters, but I have 4 of those rectangles. So I'm going to have to do some math with those numbers before I get a total area for my octagon. Okay? So now I'm going to get rid of my octagon data because I don't have a whole lot of room on this page. And now I want to find the area of one of the triangles, okay? And so we know that if we're going to find the area of a triangle, the formula is going to be area equals 1/2 the base times the height. So we plug in our numbers, and we're going to establish our base. I could just pick this as the base of one of my triangles, and I know that distance is 2 centimeters. So my base is 2 centimeters. And then what makes this easy is this distance is the same as all these other distances. And so I know now that my height is also going to be 2 centimeters. All right. So when I figure out the area of my octagon, I do half of 2, which is 1. And now I have 1 times the height. So my area of each triangle is actually 2 centimeters. Okay? Actually 2 centimeters for each triangle. Okay, so now I've pretty much decomposed and pulled together all my measurements. So now what I have to do is I have to do some multiplication and addition. So now what I'm going to do is I'm going to take I'll start with my triangles. Okay, and I'm going to add all my triangle amounts together. So I have 1, 2, 3, 4. 2 times 4 is 8. So my triangles all equal 8 square centimeters. Then what I'm going to do is my rectangles and figure out their total area. 5 of that, I have 4 sets of 5, or 4 times 5, which is 20. So I have 20 square feet for my rectangle. And then, of course, for my square, I discovered that I have 6 and 25 hundredths square centimeters in there. So now what I want to do is I want to add those all up together. Being careful to remember that I align my decimal points properly, because these are whole numbers. So I'm going to have my 8, and I'm just going to throw some decimal points in there. And then I have my 20, and I add them all up. And 5, of course, added to 0 is 5, 2 to 0 is 2. Bring down my decimal point. 6 plus 8 is 14. Regroup my 1. 1 plus 2 is 3. So the area for this octagon is going to be 34 and 25 hundredths square centimeters. All right? And that's how we would decompose or compose our polygons into something smaller and helpful in order to find the area of that polygon. All right? A lot of work involved in that. And there's many different ways of setting this up and solving it. How you want to set it up and solve it really comes down to your personal preference. All right, why don't you, on your notebook paper, why don't you try a few examples? All right, our first example is this one. Decompose this polygon so you can find the area. All right, so why don't you pause the video and see if you can find the area for this hexagon. All right, let's take a look and see how you did here. Well, the area for this hexagon is going to be 36 square feet. And how we came up with this? Well, again, it depends on what you'd like to do. But for me, what I like to do is I like to decompose my hexagon into one big rectangle like this, okay? I like to break it into one big rectangle, and then I have these two triangles right here that I can then deal with, okay? So I really have three shapes that I'm dealing with, and I could actually only have to find the area of one triangle and the area of this rectangle and then add them all up. So let's see how we do this, all right? So my rectangle, if I go ahead and look at it, okay, for my rectangle, I'll do my math. All right. The rectangle's area, it is a length of 4 and a width of 6. Again, because 6 feet and 4 feet. 4 times 6 is 24. And so there's my area for my rectangle, okay, is 24 square feet. But now I want to find the area for my triangles, okay? So my triangles will follow the formula of area equals 1/2 the base times the height. And I'm going to do the math over here so I don't run out of room. And I'm going to rewrite it, and I'm going to say, okay, my area for my triangle. My triangle has a base from here down to here, which means it's 6 feet. Okay, so I'm going to multiply 1/2 times 6, and then my height is determined by this distance. Okay, I can determine my distance from there to there as 2 feet. All right, so now all I have to do is my multiplication. 1/2 of 6, or 1/2 times 6, gives us 3. So now we have 3 times the height of 2. And then 3 times 2 is 6. So the actual area of one triangle is going to be 6 square centimeters. But remember, I have 2 of those, so I'm not done yet with my triangle data. I'm going to have to multiply 2 times 6 to get 12. And now what I can do is I can take my area from my rectangle, which is 24 square feet, my area from my triangles, which is 12 square feet, and add those up. 4 plus 2 is 6. 2 plus 1 is 3. And we do get 36 square feet for the whole hexagon. And it's a hexagon because it has 1, 2, 3, 4, 5, 6 sides. All right? Why don't you see if you can find the area for this octagon? Pause the video and see what you come up with. All right, here we go. Let's see how your how your math turned out. Now, when you decompose this octagon actually has already been decomposed for you. So you're almost going to compose it into shapes and figure out the area of the shapes. But again, you can see that we have one big square here. So what we're going to do is we're going to establish the area of the square. And of course, it's length times width. And so it's 8 feet by 8 feet. So our area of the square will be 8 times 8, which of course is 64. So the area of the square is 64 square centimeters. Now what we want to do is we want to deal with the triangles and finding out the area of all those triangles. And we can see that we actually have 1, 2, 3, 4, 5, 6, 7, 8 triangles, but we really only need to find the area of one triangle. So what I'd like to do is I'm just going to grab up this triangle right here and establish my base and height from it. All right, so my triangle, okay, my triangles I will set up to find the area, and I have to do my 1/2 of the base 4 times the height 3. All right, so the 1/2 of 4, or half times 4, will give you 2 times 3, and then of course 2 times 3 is 6. So each one of these triangles represents 6 square centimeters. All right, so now what we'd want to do is we have 8 of those, so we are going to multiply 6 times 8 in order to come up with the total area of all the triangles around the perimeter of the square. So we're going to take 6 times 8 and we will get 48. And then all we have to do is add the area of the square and the area of the triangles. So we're going to add 64 to 48. Add them up. 4 plus 8 is 12. Carry your 1. And 4 plus 6 is 10. Plus 1 is 11. So okay, why don't you see if you can solve these problems now? All right, related to these shapes. Pause the video and see what you come up with. Okay, let's take a look at what we have here. How many square centimeters of the green square are not covered by the blue square? So they want to know this green area all the way around and out here, how much of that is there in terms of square centimeters? All right, so what we're going to do is we're going to do a little bit of problem solving here. And the first thing that we want to do is figure out the area of the entire green square. Okay, so what we'll do is we'll do the green square first, and then we'll do the rectangle. Okay, well, the green square is 8 by 8 because it is a square. So what we do is we multiply 8 times 8, and that equals 64. So the green square has a total of 64 square centimeters. But now we need to find out the area of the blue rectangle. So we get the blue rectangle, and we figure out its rectangle, and we figure out its length and width, and its length is 6 centimeters, its width is 2, so that will give us an area of 12 square centimeters. All right, so then what we need to do is ask ourselves, well, if this is 12 square centimeters and the whole entire square is 64, we need to subtract then to find out what is underneath here. So we're going to take 64 and 12 and subtract. 4 take away 2 is 2, 6 take away 1 is 5. So the answer to this question is 52 square centimeters. All right. Now, that's pretty important information. So I think what we'll do is we'll save the area of the blue rectangle and the area of the green square. We'll just write them in on top there. So we're just going to write 12 here, and we're going to note this as 64 square centimeters. All right. And we can put the labels on them if we want, but it's not vitally necessary because we're still working. All right. So let's look at the next question. The next question asks, what percent of the green square is blue? Oh, so now we want to know how much of, what percentage is 12 of 64? So what we're going to do is we're going to write a fraction, okay? And our fraction is going to be 12 over 64. Okay, so we have 12 square feet for blue and 64 total square feet for the whole green square. So now we can take this and turn it into a percent. So we're going to turn it into a decimal first, and we're going to divide 12 by 64. And we have to annex our zeros at least out to the hundreds place, bringing our decimal point up. And then we ask ourselves, how many times will 64 go into 120? It will go in one time. So we have to multiply 1 times 64. We do the subtraction, and we get 56. Bring down our 0. Ask ourselves, how many times will 64 go into 560? It will go in a total of 8 times. 8 times 64 is 512. Subtract, and we end up with 48 as a remainder. But you know what? We're going to annex a 0 because we want to at least go to the 10th of a percent or be able to round, all right? So we bring down our 0 and ask ourselves, how many times will 64 go into 480? It will go in 7 times. 7 times 64 is 448. Subtract, and we're still going there. We would have 32, but we're going to stop right there because now we can say our percent, we can move our decimal point over and say that we have 18 7/7%. All right? And so when they ask us what percent of the green square, how much of this big square is blue, well, we take the square centimeters of the blue square and the square centimeters of the green square, and we find that percentage. All right? Okay, if you have any further questions related to finding the area of polygons, feel free to see your teacher or refer to your book or ask your parents for help.